Hello and welcome everyone to our new video where we are going to study Arrhenius theory of acids and bases from chapter number 5 that is acid, bases and salt. So in the previous lecture we have gone through the brief introduction of ionic compounds. Now in this lecture we are going to see the definition of acid and the definition of base. So the Swedish scientist Arrhenius put forth a theory of acids and bases in the year 1887. This theory gives definitions of acids and bases as follows. So a scientist from Sweden, okay, he has given the definition of acid and bases to us. Now let us see what is the definition given by him. So he states that an acid is a substance which on dissolving in water gives rise to H plus ion as the only cation. For example, HCl, H2SO4, H2CO3, etc. etc. Okay, so according to him, if we dissolve any compound which is an acid, okay, in that case it is going to give us H plus ion as the cation. Okay, so according to him, the definition of acid is like this, that if we dissolve acid, okay, in water, definitely the separation or the dissociation of the ion will take place, and the basic radical or the cation which will be dissociated after the mixing of the compound in the water, that basic radical is going to be H plus ion. Okay, so in any compound, if you find that H plus ion is the basic radical, okay, it is the cation, then it that case this is going to be the acid. Okay, so the examples are hydrochloric acid, sulfuric acid, that is H2SO4, and carbonic acid, that is H2CO3. Okay, so here the reaction is given to us. If I mix the HCl, hydrochloric acid, okay, in the water, it is going to dissociate the H plus ion and Cl minus ion. So HCl is going to be dissociated into H plus ion, that is cation, and Cl minus ion. Okay, so this is my basic radical and this is the acidic radical. Again for H2SO4, the dissociation will be like this, H plus ion, okay, and HSO4 minus ion, okay. And again the HSO4 will be dissociated into H plus ion and SO4 twice minus, okay, so SO4 2 minus. Now here you can see in H2SO4 the number of basic radical or the number of cation is 2. Okay, how many H plus ion are dissociated after the mixing of H2SO4 in water? There are 2 H plus ions. Okay, whereas for HCl only 1 H plus ion was dissociated, okay, after mixing of the one molecule of hydrochloric acid in water. Okay, so we have to keep the definition in mind whenever we are going to dissolve any compound in a water, and if it gives rise to H plus ion, okay, which will be the only cation present in the compound, then in that case the compound is nothing but an acid. Okay, now let us see the definition of base according to Arrhenius. So he states that a base is a substance which on dissolving in water give rise to the OH minus ion as the only anion. Okay, that is the acidic radical. For example, NaOH and CaOH twice. Okay, so again according to Arrhenius, if any compound is dissolved in water and the only acidic radical or the only anion which is generated due to the dissociation is OH minus ion, then in that case the compound is nothing but a base. Okay, so if you are dissolving any compound in water and after dissolving, the dissociation will take place if the compound is ionic in nature. Okay, and once the dissociation is taken place, okay, you will see that the acidic radical or the anion dissociated is OH minus ion. Okay, so if the anion after dissociation is OH minus ion, then we can say that the compound is a base. Okay, so the examples of base are given here, that is NaOH, sodium hydroxide, and CaOH twice, that is calcium hydroxide. Okay, so in the reaction you can see when we dissolve sodium hydroxide in water, we are going to get Na plus, it will be cation, and OH minus ion, that is an anion or the acidic radical. Okay, so the number of OH minus ion after dissolving NaOH in water is only 1. Okay, when you dissolve one molecule of NaOH in water, you will get 1 OH minus ion. Okay, then the second reaction you can see calcium hydroxide, okay, which is in solid state. It is dissolved in water and dissociation will take place. We will get Ca2 plus, okay, that is our cation, and 2OH minus, that is our anion. Okay, and in this reaction we have got two molecules of anion. Okay, so these are the example for base. Okay, when in exam, if the question is asked or the definition of the acid or base is asked to you, you have to write down the definition and also you have to give an example. And it will be more better if you give example in the form of equation. Okay, now let us see the classification of acids and bases. So the acids and bases, they are classified as strong acid, weak acid, then strong base and weak base. And also we can classify base as an alkali. So let us see what are these. Okay, so acids and bases are classified as strong and weak on the basis of the extent to which they dissociate in their aqueous solutions. Okay, so if I am dissolving NaCl, sodium chloride, okay, okay, let me change the example. If I am dissolving sodium hydroxide NaOH, okay, in water. Now, if the solution which is prepared after dissolving the NaOH in water, okay, it is 100%, the dissociation is 100%, then in that case I will say that the base is strong base. Okay, or else if the dissociation is not 100%, then I will say the solution is weak or the base is a weak base. Okay, let me give one more example. Okay, if you are dissolving sugar in the water and the solution which is generated or the sugar is completely dissolved, okay, in the water, then we can say the solution is strong solution. Okay, but if the sugar is not completely dissolved in the water, okay, the solution is not 100% true, then we can say that the solution is a weak solution. Okay, so now let us see what is strong acid. On dissolving in water, a strong acid dissociates almost completely, and the resulting aqueous solution contains mainly H plus ions and the concerned acidic radical. For example, HCl, HBr, HNO3, and H2SO4. Okay, we have to keep in mind if we are dissolving any acid in the water and the complete dissociation has taken place. That means each and every molecule has been dissociated in the solution. Okay, then we can say that the resulting aqueous solution, okay, is nothing but a strong acid. Okay, so if any acid is dissolving completely in the water, okay, we have dissolved each and every molecule, and each and every molecule has been dissociated into its H plus ion and also into its acidic radical. Okay, then we can say that the acid is a strong acid. Okay, so अगर आप किसी एसिड को पानी में मिला रहे हो और वो एसिड कंप्लीटली पानी में मिल जाता है, ओके, और उसमें जितने भी मॉलिक्यूल्स है एसिड के वो सब डिसोशिएट हो गए हैं, ईच एंड एवरी मॉलिक्यूल जो है एसिड का उसमें से कटायन और अनायन सेपरेट हो चुका है, सो इन दैट केस वी कैन से दैट द एसिड इज अ स्ट्रॉन्ग एसिड. यहाँ पे स्ट्रॉन्ग एसिड के एग्जाम्पल दिए हुए हैं HCl, दैट इज हाइड्रोक्लोरिक एसिड, HBr बोरिक एसिड, HNO3 nitric acid, and H2SO4, that is sulfuric acid. Okay, so all these acids are nothing but strong acids. Okay, now let us see the definition of weak acid. Definitely weak acid is going to be vice versa of strong acid. Okay, so in weak acid what we will see that the dissolution is not going to be 100%. So जब आप एसिड मिलाओगे पानी में और वो अगर एसिड कंप्लीटली पानी में मिलता नहीं है या फिर जो मॉलिक्यूल्स है वो 100% डिसोशिएट नहीं हो रहे हैं। ओके, सपोज कुछ मॉलिक्यूल्स है एसिड के जो सेपरेट नहीं हो रहे, जिसमें आपको कैटायन और एनायन सेपरेट नहीं दिख रहा है, वो एक साथ फिर अभी भी कंबाइंड है। इसका मतलब क्या है कि वो जो एसिड है वो क्या है, वीक एसिड है। सो ऐसा एसिड जो पानी में 100% मिलता नहीं है, जिसका 100% डिसोसिएशन नहीं होता, उस एसिड को हम लोग क्या बोलेंगे, वीक एसिड। ओके, सो ऑन डिसॉल्विंग इन अ वाटर a weak acid does not dissociate completely and the resulting aqueous solution contains H plus ion and the concerned acidic radical in small proportion. Okay, so the proportion of H plus ion and the acidic radical is going to be very much small. Okay, and the large proportion of the solution will be have they it will have undissociated molecules of the acid. Okay, so the examples of weak acid are CH3COOH, that is the molecular formula of acetic acid. Okay, and I think this is the wrong example. We must have here HCO3, that is carbonic acid. Okay, CO2 is not an acid, so we must have an example HCO3, that is carbonic acid. Okay, so these are the examples of weak acid. Now let us see the definition of strong base. On dissolving in water, a strong base dissociates almost completely and the resulting aqueous solution contains mainly OH minus ions and the concerned basic radicals, for example NaOH, KOH, COH twice and Na2O. Okay, so any compound, okay, or any base which is 100% dissolved in the water, and we see that the anion and the acidic radical, okay, anion and the basic radical has been dissociated completely, then we can say that the compound is a strong base. Okay, so अगर आप बेस को पानी में मिला रहे हो और आपको वहां पर 100% डिसोसिएशन देखने मिलता है अनायन का और कटायन का, तो हम क्या बोलेंगे कि जो कंपाउंड है वो क्या है, स्ट्रॉन्ग बेस है। एग्जाम्पल क्या है स्ट्रॉन्ग बेस के, सोडियम हाइड्रोक्साइड, पोटेशियम हाइड्रोक्साइड, ओके, कैल्शियम हाइड्रोक्साइड एंड सोडियम ऑक्साइड। ओके, then weak base. Okay, what are the examples of weak base? Let us see what is weak base first. On dissolving in water, a weak base does not dissociate completely, and the resulting aqueous solution contains a small proportion of OH minus ions and the concerned basic radical along with a large proportion of undissociated molecules of the base. For example, NH3. Okay, so any base, okay, which on dissolving in water does not dissociate its ions completely, then in that case we can say that the compound or the base is a weak base. Okay, and the example of weak base is given here, that is NH3. Okay, so ammonia is the example of weak base. Okay, this example particular, that is CO2, it is also correct example. Okay, when we mix CO2 in a water, we are going to get the carbonic acid and again the dissociation will take place. So this is also correct example for weak acid. Now let us see what is alkali. So the bases which are highly soluble in water are called alkali. That means the strong base can also be referred as an alkali. Okay, strong base को हम लोग alkali भी बुला सकते हैं क्योंकि ये वाटर में क्या होते हैं, हाईली सोल्यूबल होते हैं, आराम से ये पानी में डिजोल्व हो सकते हैं, इसलिए इन्हें अल्कली कहा जाता है। एग्जाम्पल क्या है इसके, NaOH सोडियम हाइड्रोक्साइड, KOH पोटेशियम हाइड्रोक्साइड, NH3 अमोनिया। ओके, एंड वी हैव टू कीप इन माइंड दैट NaOH और KOH क्या है, स्ट्रॉन्ग बेस है, इसलिए हम इसे स्ट्रॉन्ग अल्कली कहेंगे। और NH3 क्या है, वीक बेस है जो 100% कंप्लीटली डिसॉल्व नहीं हो सकता, या फिर आपको यहाँ पर डिसोशिएशन ऑफ आयंस नहीं देखने मिलेगा, इसलिए ये क्या है, वीक बेस है। लेकिन इसे हम लोग अल्कली की कैटेगरी में रख सकते हैं क्योंकि अमोनिया भी क्या होता है, आसानी से पानी में मिल जाता है, सिर्फ डिसोसिएशन ऑफ आयंस नहीं होगा। Okay, so in this lecture we have seen what is acid, what is base, okay, and also we have gone through the definitions of strong and weak acids and bases respectively. Okay, now in the next lecture we are going to see what is basicity and acidity. Okay, and also we are going to see the concentration of acid and base in the next lecture. Okay, for this lecture your homework will be, you have to write down the molecular formulas and molecular names of several compounds, okay, and which is given in the description, you will find one link. Click that link and you will see the formulas and molecular names. Okay, note down those molecular names and formulas in your notebook and also learn the formulas properly. Okay, so this is it for today's lecture. In the next lecture, we are going to deal with the points from this chapter. Okay, until then, goodbye.